All right, let's get right into it. Today, we're going to deep dive into something truly wild. Germany's ambitious project to develop a hypersonic spaceplane.
Nicknamed Aurora.
Exactly, Aurora. And, this thing could really change how we think about space travel and military power, not just for Germany, but maybe for all of Europe.
Yeah, and what's really incredible is we're talking about a two-stage system here. Basically, like, picture a space plane riding piggyback on a rocket.
Okay.
And this two-part design is fully reusable.
How?
And could be ready to go as early as 2028.
Okay, so 2028 that's right around the corner. For those of us who aren't, rocket scientists, can you break down what hypersonic flight even means and why it's such a big deal?
Sure. So hypersonic flight basically means traveling at speeds greater than Mach 5.
Correct.
Which is 5 times the speed of sound.
Wow.
To give you an idea of what that means, it's like traveling from New York to LA in under an hour.
That's incredibly fast. So what makes this so hard to do?
Well, at those speeds, you're not just trying to get something to move that fast.
Right.
You're also dealing with the immense heat that's generated from air friction.
Oh, yeah.
And the incredibly complex aerodynamics involved.
So it's a huge, huge engineering challenge.
A whole different ballgame compared to, normal flight.
Yeah. So why is Germany pouring resources into this? What's pushing their ambition?
Well, there are a few factors at play here.
Okay.
One is the desire to stay ahead in, global technological advancement, especially with China's rapid progress in hypersonic technology.
Okay.
This isn't just about scientific achievements. It has big implications for global security. It could potentially shift the balance of power.
It's like a new space race, but with way higher stakes.
Yeah, you could say that.
So tell me more about Aurora itself. What makes it so unique?
So Aurora is designed to be fully reusable, much like the space shuttle,
Okay.
but potentially even more efficient and cost-effective.
Got it.
The idea is it takes off from a runway, like a normal plane,
Yeah.
climbs into space, and then comes back to Earth for a smooth landing,
Wow.
ready for its next mission.
It sounds like something straight out of a science fiction movie.
Right.
So tell me more about how this two-stage system works.
So picture this, a powerful rocket booster that provides the initial thrust to get Aurora off the ground and high into the atmosphere.
Okay.
Once it reaches a certain altitude, the spaceplane detaches from the booster and uses its own engines to accelerate further, eventually hitting those hypersonic speeds.
So it's raw power
Yes.
and then a more refined propulsion system.
Exactly, a combination of both.
Who are the masterminds behind all of this?
So the development of Aurora is being spearheaded by a German startup called POLARIS Raumflugzeuge.
Okay.
What's fascinating is their iterative approach to development.
Okay.
They've been meticulously testing smaller scale prototypes called Mira. And they've already racked up over 100 successful test flights
Wow.
with these smaller versions.
That's a really smart approach. Learn and refine with each test.
Exactly. They're taking their time.
But I can only imagine, the massive engineering challenges to build something like Aurora.
Oh, absolutely. We're talking about pushing the boundaries of aerospace engineering.
Yeah.
There are 3 key hurdles: propulsion, thermal management, and aerodynamic design.
Okay, let's break those down. So first, propulsion. What makes that so difficult?
Well, you need an engine, or a system of engines, rather,
Right.
that can handle both. The powerful thrust needed for the initial ascent, like a traditional rocket, and then transition seamlessly to air-breathing engines
Okay.
for that sustained hypersonic flight.
Oh.
Achieving that smooth transition is incredibly complex.
It's like having 2 different engines in one.
In essence, yes.
And what about thermal management? I mean, at those speeds, it must generate so much heat.
Oh, the heat generated at Mach 5 plus is intense.
Yeah.
We're talking temperatures that can melt conventional aircraft materials.
Right.
So Polaris is exploring some cutting-edge solutions,
Like
using high-temperature ceramics
Yeah.
and developing very sophisticated cooling techniques to protect the craft from those extreme temperatures.
So they're working with materials that can withstand, the heat of a furnace?
It's incredible, isn't it?
Yeah. While traveling at 5 times the speed of sound, that's crazy. Okay, and finally, aerodynamic design. What makes that so challenging?
It's all about balance.
Okay.
You need a design that's incredibly sleek and aerodynamic to minimize drag at those speeds, but at the same time, it needs to generate enough lift for controlled descent and a safe landing back on Earth.
Right.
Finding that perfect balance between those two demands is a monumental task.
So all of this comes together to create this incredible vehicle, but what can it actually do? What are the practical applications?
That's where things get really interesting. Aurora is being designed for what we call dual-use capabilities.
Dual use.
Meaning it can be used for both scientific research and military purposes.
That's a versatile tool.
It is.
What kind of scientific research are we talking about?
Aurora could change the game for a lot of scientific disciplines.
How so?
Imagine conducting experiments in hypersonic flight,
Okay.
gathering data on how materials behave at those speeds, or studying the upper atmosphere in ways we never could before. The possibilities are pretty much endless.
It's like a flying laboratory.
Exactly. A flying laboratory pushing the boundaries of scientific understanding.
The data that it could get could have implications for everything.
Oh, absolutely. From improving commercial air travel to understanding climate change even better.
That's remarkable. But let's talk about the military side of things. What kind of advantage could Aurora give Germany?
The military applications are potentially huge.
Sure.
For example, Aurora could be used to deploy small satellites quickly and independently, giving Germany more control over its space-based assets.
Got it.
It could also be used for real-time reconnaissance from space,
Wow.
allowing for rapid intelligence gathering from orbit.
So we're talking about potentially game-changing intelligence gathering and space-based capabilities.
Absolutely, that's what we're looking at.
Are there any other potential military applications?
Well, Aurora could even be used for high-speed testing of new weapon systems, allowing for the development and evaluation of advanced technologies in a more realistic environment.
So the possibilities are really remarkable.
They are.
It sounds like Aurora could give Germany a significant advantage in a lot of areas, but this type of technology, this has got to have wider geopolitical implications. Right?
Oh, absolutely. You can't ignore the geopolitical context here.
Yeah.
China's rapid progress in hypersonic tech is a key driver for Germany's investment in Aurora. And the development of this capability within NATO raises some important questions about European independence when it comes to defense.
Could this start a new space race with hypersonic tech as the prize?
It's a possibility.
This is getting intense, but realistically, how soon could we see Aurora in action?
Well, they're working with a very ambitious timeline. They're aiming for operational readiness by 2028. We should be seeing some major milestones soon, including a flight test of an 8-meter prototype by the end of this year.
That's a tight timeline.
It is.
But it sounds like they're making good progress. What are some of the innovations that are making all of this possible?
Polaris is really pushing the boundaries in a few key areas. One is propulsion.
Okay.
They're developing these hybrid propulsion systems that combine traditional rocket boosters with potentially scramjet engines.
Scramjets. That sounds so futuristic.
They are pretty amazing.
How do those even work?
Scramjets are fascinating. They're a type of air-breathing jet engine, specifically designed for hypersonic flight.
Okay.
Unlike conventional jet engines, which use moving parts to compress the incoming air,
Right.
scramjets use the craft's incredible speed to compress the air, which makes them much more efficient at those high velocities.
So it's using the sheer speed to its advantage.
Exact.
That's brilliant. What other innovations are they incorporating?
Well, they're also making some breakthroughs in thermal protection.
Right, because managing the heat at those speeds is critical.
It is, and Polaris is working on these advanced thermal protection systems that use a combination of high-tech materials and innovative cooling techniques to keep the craft from, well, melting.
It's mind-blowing to think about all the science and engineering that goes into this.
I know, it's really incredible.
It's like something out of a futuristic movie, but it's happening right now. This is all super exciting, but I think it's important to step back for a second and think about the bigger picture. What does the development of Aurora mean for Germany, for Europe, for the future of space exploration and military technology?
That's the million-dollar question. If Aurora is successful, it could really change how we think about space access and military capabilities. It's a clear sign that the future is being built now, and it's moving at hypersonic speed.
We'll definitely be keeping a close eye on Aurora's progress and keep you informed every step of the way. This is a story that's just beginning to unfold, and it has the potential to be truly groundbreaking. Before the break, we were talking about the potential impact of Aurora, Germany's hypersonic spaceplane project. And it's not just about the cool technology, is it? This has the potential to really change Germany's place in the world.
It does. Developing this kind of cutting-edge technology, it really says a lot about Germany's ambitions and how they see themselves on the global stage.
What I find interesting is how this might impact Germany's role within NATO. You mentioned like greater European independence and defense, but what does that look like practically speaking?
Right now, a lot of European countries rely on the U.S. for certain military capabilities.
Right.
Particularly when it comes to space, things like satellite intelligence, secure communications.
It makes sense that access to space is becoming more and more important these days.
It is. And if Germany successfully develops and deploys Aurora, it could give Europe a level of independence that they haven't had before when it comes to, space-based assets.
That's a big shift. So Europe could potentially handle more of its own defense without relying so much on U.S. support. Wouldn't that create some tension within NATO? I mean, the U.S. has always been the dominant force.
It's possible, yes, some in the U.S. might see it as a challenge to their leadership, but there are also arguments that a stronger and more independent Europe could actually benefit NATO as a whole.
Okay, that's an interesting perspective. How so?
Well, a more balanced alliance where the burden of defense is shared more evenly could make NATO stronger and more resilient when facing global challenges.
So potentially a win-win for everyone involved. But what about beyond NATO? How might Aurora change the way other countries view Germany?
I think it's safe to say that a successful hypersonic spaceplane program, it would really boost Germany's international standing.
Yeah.
It would showcase their technological abilities and their commitment to innovation.
It's like saying, hey, we're not just an economic powerhouse. We're a major player in this space race.
Exactly. And with that comes influence when discussing space security and other important global issues.
Speaking of global players, let's talk about China for a second. You mentioned their advancements in hypersonic technology as a driving force behind Germany's interest in Aurora.
There's no doubt that China's rapid progress in areas like hypersonic missiles and space capabilities, it's raised concerns in a lot of Western capitals.
So Germany's pursuit of Aurora could be seen as a direct response to those concerns.
Absolutely. It shows that they're taking the challenge seriously and they're willing to invest in the technologies that can counter those advancements.
It sounds like we could be on the edge of a new arms race, not just in traditional weapons, but also in hypersonic and space. Is that a real possibility?
It's a real concern. We're already seeing it happening, with the U.S. speeding up its own hypersonic programs in response to China.
Right.
And with Germany now entering the game, things could escalate pretty quickly.
So it's not just about the technology, it's about geopolitics, strategic positioning, and maintaining a balance of power globally.
You got it. Technological advancements are never developed in a vacuum.
Right.
They're always tied to political, economic, and security considerations. And with hypersonic technology, these considerations are especially complex.
We've been talking a lot about the strategic side of things, but let's talk about the economics for a minute. This project must be costing a fortune.
Oh, it is. Developing and deploying a hypersonic spaceplane, it's incredibly expensive. We're talking billions of dollars.
So with that kind of price tag, what's the return on investment? Why is Germany willing to spend so much?
There are a few reasons. First, as we've discussed, the strategic and security benefits are huge.
Yeah.
But there are also big economic benefits to think about.
Like what?
Well, for one, projects like this, they drive innovation and technological advancement.
Okay.
They push the limits of what's possible in aerospace engineering, material science, propulsion systems, so many fields.
So it's not just about building one spaceplane, it's about moving the whole field of technology forward.
Exactly. And those advancements can then lead to breakthroughs in other industries.
Okay.
The tech developed for Aurora could potentially be used in commercial aviation, space exploration, even high-speed transportation here on Earth.
So the investment in Aurora could create new industries and open up all kinds of new economic opportunities.
Exactly. And don't forget about the jobs created by a project this big.
Right.
We're talking high-skill, high-paying jobs in engineering, manufacturing, research and development. It's a big boost to the German economy.
So it's not just about military power, geopolitics. It's also about economic competitiveness, establishing Germany as a tech leader. It sounds like they're playing the long game.
They are, and it'll be really interesting to see how it plays out.
Absolutely. But let's bring it back down to earth for a second. What are the next steps in the development of Aurora? What should we be watching for?
Well, the next big milestone is the flight test of the 8-meter prototype, which is scheduled for later this year.
That'll be a make-or-break moment, won't it?
It will, yeah. It's the first time a smaller version of Aurora will actually fly. It'll give the engineers a chance to collect data on the aerodynamics, the propulsion system, how well the heat shield works in real-world conditions.
So a lot riding on that test flight. What happens if it all goes well?
If the test is successful, the next step is to build the full-size 28-meter Aurora,
Okay.
the one that will eventually carry a payload into orbit.
That's when we'll really start to see what this thing can do.
Exactly, but it's important to remember that this project is still in the early stages.
Right.
There are going to be challenges and setbacks along the way.
Yeah, developing a hypersonic spaceplane is no easy task.
It's not.
There are so many technical hurdles, and you never know what political or economic issues might pop up.
That's true. So while it's exciting to think about the possibilities, it's also important to, be realistic and be aware of the complexities.
It's a project with a lot of unknowns, but it's definitely one worth watching. It could change the technological landscape, the global balance of power, and maybe even the future of space exploration.
I totally agree. It's a bold and ambitious undertaking, and the outcome is still uncertain. But one thing's for sure, the world will be watching.
And so will we. We'll keep you updated on all the latest developments, but for now, we're going to explore some of the bigger implications of hypersonic technology, not just for Germany, but for all of us.
Welcome back to the Deep Dive. We've been talking about Germany's hypersonic spaceplane project, but before we wrap things up, I think we should really consider, what this all means for the bigger picture.
Yeah, you're right. This technology, it has implications that go way beyond Germany. It raises some big questions about the future, not just a technological future, but, for society and even, philosophically.
Okay, so let's get into that. What are some of the things we should be thinking about? I think one of the biggest concerns is the potential for, the militarization of space. We've already seen growing tension and competition in space, and technologies like Aurora could make that even worse.
So it's not just about who gets to space first, but what they do when they're up there.
Exactly, and that brings up some complicated ethical and legal questions.
Like what?
Like, what are the rules of engagement in space? How do we prevent a space arms race that could destabilize the whole planet? These are not simple questions to answer.
These are questions that need serious thought and discussion.
Yeah, on a global scale. But beyond the security implications, there are also some wider societal and even philosophical questions to consider.
I'm curious, what are some of those?
Think about how this tech could change how we understand, time and distance. If we can travel at hypersonic speeds, it makes the world feel smaller in a way we've never experienced before.
That's true. It makes you wonder about the future of travel, commerce, even cultural exchange. It's mind-boggling.
Right. Imagine going from Berlin to Sydney in a few hours. It would completely change our relationship with time and space, and that could have a huge impact on our societies and cultures.
It makes you think about our place in the universe.
It does.
And how technology can, change how we see it.
It's exciting and a little scary at the same time, right?
Yeah.
As we keep pushing the boundaries of what's possible, we need to be responsible and really think about the consequences.
So as we wrap up this deep dive into Germany's hypersonic ambitions, what are some key takeaways you'd like our listeners to, think about?
I think the biggest takeaway is that we're living in a time of huge change in space exploration and technology. The things we're seeing in hypersonic flight, access to space, and all the related fields, they're changing our world so fast.
And it's not just about the tech itself. It's about the wider impact on society, ethics, and even how we understand ourselves and our place in the universe.
Exactly. It's a story that's still being written, and we all have a part in writing it through the choices we make and the conversations we have.
That's a great point to end on. It's a reminder that technological progress should go hand in hand with thinking about its impact on humanity. Thanks for joining us on this deep dive. We hope it's made you curious and given you a lot to think about. Until next time, keep exploring and keep asking those big questions.